Hey everyone, and welcome. Today, we are going to tackle one of the biggest, most common questions in all of data science. How in the world do you choose the right AI algorithm for your project? It can feel like you have a million options, but trust me, we're going to build a super clear map to help you find your way. Let's just dive right in. So if you've ever found yourself staring at your data asking this exact question, you are in very, very good company. It's pretty much the classic starting point for anyone about to get their hands dirty on a new project. The great news? There's a really logical way to think about this, and by the end of our chat today, you're going to have it down cold. So instead of me just throwing a giant list of algorithms at you, we're going to do something way more useful. We're going to build a mental model together. Seriously. Think of it like a decision-making map that'll guide you from your problem straight to the perfect algorithm, pretty much every time. Okay, let's get into it. Every single journey with data, no matter how complex, starts at the exact same place. It starts with one single fundamental question that literally splits the entire field of machine learning right down the middle. This right here, this is the critical fork in the road. Before you write a single line of code, you have got to answer this question. Is your main goal to predict a future value, an outcome, or some kind of specific label? Your answer to this is going to determine everything that comes next. So if your answer is a big yes, then congratulations. You're in the world of supervised learning. The easiest way to think about this is that you're learning with an answer key. You have old, labeled data that you can use to teach the algorithm. Now, if your answer is no, you're heading down the path of unsupervised learning. And here, the goal is totally different. You're asking the algorithm to find hidden patterns and structures in the data all by itself. All right, so let's follow that yes path first. You've decided your goal is to make a prediction. Awesome. So what's the next stop on our map? This is your very next decision point. What does your prediction actually look like? Is it a number that could fall anywhere on a spectrum, like the price of a house? Or is it a distinct label, like spam or not spam? If you're predicting a number, what we call a continuous value, then the task you're doing is called regression. This is the absolute perfect tool for forecasting things like sales numbers, stock prices, or even tomorrow's temperature. And the key here, you'll hear me say this again, is to start simple. Linear regression is the workhorse of prediction for a reason. It's fast, and it's easy to understand what it's doing. Now, if you find your model is getting a little too complicated or it's overreacting to your training data, that's your signal to try a more robust method like regularized regression. But what if you're not predicting a number? If your goal is to assign a label, like figuring out if an email is junk or if a customer is probably going to buy something, then you've entered the world of classification. And guess what? We again start with a powerful but really interpretable model, logistic regression. It's awesome because you can actually see why it's making a certain prediction. But if you need to squeeze out every last drop of accuracy and you're okay with a model that's a bit more of a black box, that's when you bring in the heavy hitters like a random forest or gradient boosting. So if this whole prediction path feels like where you're going to be spending most of your time, a really fantastic resource to master these techniques is the Machine Learning Full Course from Edureka. It goes into these core supervised learning concepts in amazing detail. Okay. Let's back up to our first big question. What if your answer was no? You're not trying to predict anything. Well, let's explore that other main branch, the pattern path of unsupervised learning. On this path, your whole goal is pure discovery. So the next question becomes, what kind of discovery are we talking about? Are you trying to find natural, hidden groups in your data? Or are you just trying to simplify it by boiling down a bunch of variables? If your main goal is to group things, let's say you want to segment all your customers into different types based on how they shop, then what you need is a clustering algorithm. It's an incredibly powerful way to let the data tell you about its own hidden structure. And yep, that start simple principle applies here too. K-means is the absolute go-to for finding straightforward, kind of circular groups in your data. Now, if you think your groups might have more complex shapes or even nested structures, then you can explore more advanced methods like DB-scan. Now for the other side of this unsupervised coin. Let's say your data set has hundreds, maybe even thousands of columns. It's just too much to handle. That is where dimensionality reduction comes in to save the day. It's basically a set of techniques for distilling all of those features down to just a few essential components that still capture the soul of the data. What's really cool here is that the right algorithm totally depends on your specific goal. For general purpose reduction, just to speed up other models, PCA is the undisputed industry standard. But if your goal is purely to see the structure in your data, to visualize it, t-SNE is just incredible. And if you're working with text, you've got specialized tools like topic modeling that can pull out hidden themes from thousands of documents. So to really get your hands dirty with these pattern-finding techniques, that same Edureka machine learning course is a great place to start for clustering. And for all those text-specific methods we just mentioned, their natural language processing full course is the perfect next step.
Okay, so we've built our foundational decision map. But you know this is just the beginning, right? Let's quickly look at the journey ahead and how you can level up your skills from here.
This roadmap is what really takes you from a practitioner to a true expert. You'd start by mastering deep learning to handle really complex problems with images or text. Then you can explore advanced stuff like reinforcement learning. That's what powers self-driving cars, before specializing in NLP. And finally, tying it all together to build real applications with frameworks like LangChain. All right, let's bring this all home. This simple map we've built isn't just theory. It's your key to walking into any data science project with confidence. Just burn this framework into your mind. If you're predicting, you go supervised. If you're finding patterns, you go unsupervised. Then you just ask the next question on the map to narrow it down even more. Always start with the simplest, most common model first. And finally, know that there's a clear path that takes you from these fundamentals all the way to the cutting edge. And there you have it, your map for choosing the right AI algorithm. So I guess the only question left is, what problem are you gonna solve first? Thanks so much for watching.